Hi there, and welcome to the University of Utah Electronics Training Module. I'm Dr. James Nagel, and today I would like to teach you about the digital multimeter. One of the most useful devices in any electrical toolkit is the digital multimeter. As the name implies, a multimeter is simply an electronic instrument that measures two or more electrical values. At a minimum, this will almost always include voltage, current, and resistance, but there are many other capabilities that a typical multimeter might provide. Nowadays, most multimeters will use digital displays to present information, and so they are naturally called digital multimeters. This is in contrast with analog multimeters, which used to be far more common in the past and used analog displays for their measurements. Some multimeters, like this one here, are said to be portable or handheld, meaning they are small, lightweight, and powered by batteries. This allows them to be easily picked up and carried around so that measurements may be taken in remote locations. Other multimeters, like this one here, are strictly benchtop instruments, meaning they're powered by ordinary wall plugs. As such, a benchtop instrument is generally intended to stay in one place when performing measurements. Let us now use a multimeter to measure the voltage across a simple battery. For this demonstration, we will be using the WaveTech MeterMan 35XL. If you do not have a 35XL, but instead have some other digital multimeter, then that's probably okay. Most multimeters tend to share the same markings and functionality, so it shouldn't really matter what specific device you have. We will also be measuring a simple 9-volt battery, but any off-the-shelf battery will work just as well. Start by making sure that the red test cable is plugged into the voltage terminal, which is typically marked with a little V underneath. If not already plugged in, take the little black cable and plug it into the COM terminal for electrical common or simply ground. Next, spin the dial to the little V symbol with the flat bars above it. This will measure a constant or DC voltage. Now take the metal tip of the red or positive probe and touch it to the positive lead on the battery. While maintaining contact, take the black or negative probe and touch it to the negative terminal. Be careful not to touch any of the metal contacts with your fingers, as this may potentially corrupt the measurement. If the battery is fully charged, then you should observe a value of about 9 to 9.5 volts appear on the display. Disconnect the terminals and watch the display now. You may notice that the values start jumping around randomly. This is normal behavior whenever the probes are not connected to a voltage source. Finally, switch the positive probe with the negative and then measure the battery voltage again. You will notice that the same value appears on the display, but with a negative sign. Let us now use the multimeter to measure an alternating voltage. For this demonstration, all you will need is an ordinary wall outlet. To begin, twist the dial to the AC voltage setting indicated by the little V symbol with a squiggly line above it. Next, insert the probes into the vertical receptacles of the wall plug. You should immediately notice a value of about 120 volts, which is the typical RMS value for American electrical power. Be especially careful to keep your fingers clear of any metal contacts, as this level of voltage can be dangerous. Finally, swap the positive probe with the negative and then measure the outlet again. You will notice that the sign of the voltage has not changed. This is because alternating voltage does not have any special preference for one direction over another. For the next demonstration, we shall use our multimeter to measure resistance. I will be using a typical 1 kiloohm resistor, but you should be able to follow along with any resistor you like. Begin by twisting the dial to the resistance setting, which is typically indicated by a capital Omega symbol representing ohms. Take a close look at the port with the red cable in it. You may notice that there is also a little omega symbol next to the V. This is normal, and it just means that the port used to measure resistance is the same port used for measuring voltage. At this point, your display will probably show something like OL. This simply means that the meter is measuring an open loop, or infinite resistance, as one might expect when there is nothing connected to the probes. Now take the two probes and touch them together. You should immediately see a resistance of almost 0 ohms, but not quite. This is normal, and it simply represents the internal resistance of the cables themselves, which is usually a few tenths of an ohm. Next, take the two probes of your multimeter and touch them to the contacts of the resistor. As you can see, a resistance of about 1 kiloohm now appears on the digital display. Don't worry if the resistance isn't exactly 1000 ohms, since all resistors will have some finite tolerance. You may also notice that it doesn't matter which probe touches which contact, as the resistance will be the same either way. Another highly useful feature of the multimeter is the continuity test. All this does is indicate whether or not 2 points are electrically shorted. To begin, spin the dial to the continuity setting, which is usually marked with a little sound wave cartoon. Next, simply touch the 2 probes to any electrically continuous contacts. When the circuit is closed, you should hear the meter emit a distinct beep. We shall now use the multimeter to measure current. For this demonstration, we will require a battery, a resistor, and 2 alligator clips. Before we begin, it is important to always remember that voltage and current are very different measurements. As such, each one utilizes entirely different circuitry within the multimeter. It is therefore necessary to transfer the red cable from the voltage port to the appropriate current port. You may notice, however, that the multimeter has 2 such ports. The first is intended for very low currents, and so it is usually marked with microamps or milliamps to indicate the appropriate scale. The second port is used to measure very high currents, and so will often be marked with something like 10A to indicate a maximum current of 10 amps. Start by removing the red cable from the voltage port and then inserting it into the low-scale current port. Next, spin the dial to the milliamp setting on the multimeter to set the desired scale for the measurement. Using an alligator clip, connect the positive terminal of the battery to one of the resistor contacts. Using the second alligator clip, connect the opposite resistor contact to the positive probe of the multimeter. Touch the negative probe of the multimeter to the negative terminal of the battery. This will create a series connection through the ammeter and thus complete the circuit. Given a 9-volt battery and a 1 kiloohm resistor, we can clearly see that the measured current is a little over 9 milliamps. Finally, switch the positive probe of the multimeter with the negative. As we can see, the current has the same value as before, but again with a negative sign. Congratulations! You are now ready to measure basic electrical properties with a digital multimeter.